Welcome back to the channel. In this lesson, we'll continue with our lessons on how to calculate electric force between 3-point charges. Here, we'll be seeing 3-point charges at right-angled triangle. As you well know, our lessons are well suited for grade 11 and 12 students and likewise for science and engineering students in part 1 and part 2. That said, let's get into class. Example says we have three charges. One is positive 10, negative 20, and negative 16. They are distributed as shown, and what we have here is they form a right angled triangle. So we should find the resultant force acting on the 10 Coulomb charge. We're interested in the 10 Coulomb charge. Now, because the 10 Coulomb charge is positive and the 20 is negative, definitely there will be a force of attraction. So I expect my force to be in this direction. Because the 10 Coulomb and the 16 Coulomb also is positive and negative, there will be a force of attraction. So I expect my force to be in this direction. Now, if you look at these two forces, let's tag this force F1 and force what? F2. F1 and F2, they meet at a right angle. They should form something like this so that I have a right angle here. Okay, now the first thing I want us to do, like we did in our last lesson, is to calculate force F1. In case you missed our last lesson, please don't hesitate to check the description below. We'll place a link to that lesson. And to ensure you don't miss our lessons, kindly do hit the subscribe button and the notification bell. That way you'll be sure to get our lessons anytime we create them. Now, the force F1, our force generally is always given as K, Q1, Q2 over R squared, where K is a constant and K is 9 times 10 raised to power 9. R is the distance, this time around between 10 and the 20 Coulomb, that's 3. Then we can tag our Q1 to be the same thing as 10 coulombs and Q2 to be the same thing as 20 coulombs. So that my force F1 this time around will be given as 20 times 10 times 9 times 10 raised to power 9 all over 3 times 3. That's 3 squared. Well, this is 9. 9 here is 1. It will cancel this 3. 3 times 3 is 9. So I'll be left with my F1 to be the same thing as 20 times, here is 10 raised to power 1 plus 10 raised to power 9. That will be 20 times 10 raised to power 10 Newton. The same way we can solve for F2. My F2 will also be equals to K, the constant, which is 9 times 10 raised to power 9 times Q. Q1 in this case is 10 again, and Q2 in this case is 16. All over the distance between them is 2. 2 squared, that will be 2 times 2. So that F2 will be the same thing as 2 here is 1, 2 in 16 is 8, 2 here is 1, 2 in 16 is 4. Now I have 4 times 9, that's 36, times 10 raised to power 10, because I have 10 raised to power 9 and 10 raised to power 1. That becomes 10 raised to power 10 Newton. Now both forces, if you look at it carefully, you see that both forces are at right angle to each other. Now we can use our parallelogram rule, or we can just find the resultant by resolving both forces. But I want to use my parallelogram rule for convenience and for me to be able to explain better. Now here is F2 for my parallelogram rule, and this way again will be F1. So I can draw my resultant this way. Here's my resultant. Let's call my resultant force F. Obviously, from trigonometry, we know that force F now will be the same thing. The square of force F, or rather force F, or the square of force F will be the same thing as the square of F1 plus the square of F2. So that F now will be the same thing as the square root of F1 squared plus F2 squared. So that F now will be the same thing as square root of F1 squared plus F2 squared. That will be the same thing as 20 times 10 raised to power 10 all squared again plus 36 times 10 raised to power 10 all squared. Obviously, F now is the same thing as the square root of 20 squared, that's 400, times 10 raised to power 20 plus 36 times 36, that's something as 1296 from my calculator, times 10 raised to power 20. So that F now, if you calculate from this, F obviously will be the same thing as 41.183 times 10 raised to power 10 Newton, times 10 raised to power 10 Newton. That's the resultant force. But to actually determine the resultant, we need to talk about the angle at which this force is acting. So we can define theta this way, so that let's place here is theta, so that from here, from trigonometry, we know that tan theta is the same thing as f1 over f2. My f1, from what we got initially, our f1 is the same thing as 20 times 10 raised to power 10 Newton, and our f2 is the same thing as 36 times 10 raised to power 10 Newton. This is tan theta. So that 10 raised to power 10 cancels 10 raised to power 10, Newtons cancels Newton. So I'm left with 20 over 36. So that theta now is the arctan of 20 over 36 from my calculator, that's 0.555. So that theta invariably is the same thing as 32.28 degrees. 32.28 degrees. Will this help you further understand how to calculate electric force between 3-point charges at a corner? Thank you for staying with us, and see you in our next class.